Hello guys, welcome to Collegewali PADHAI. So today we are at the episode 4, this is 4 of chemistry. Let me write it properly. Episode 4 of chemistry, in which we are going to learn about double salt and coordination compounds. So basically addition compounds can be formed by stoichiometric amounts of two or more stable compounds joined together. Let's take the example of these two equations. KCl plus MgCl2 plus 6H2O. On combining, we get their product as carnallite. Then, this is the example of double salt. But for coordination compound CuSO4 plus 4NH3 plus H2O, we again get a product of these three, which is tetramine copper 2 sulfide monohydride, mono, single compound. So there are basically two types, one which loses its identity, another which retains its identity. Another example is CuH2O whole 6 whole 2 plus charge plus 4NH3 reversible reaction. It will come as CuH2O whole 2 NH3 whole 4 2 plus 4H2O plus 4H2O it will come. Here it is written. Then we will come to Warner's experiment. What did Warner explain? Warner explained about the nature of chemical bonding in some of the complexes. So it shows two types of valency. One is the primary one and another is the secondary one. Primary one is non-directional, secondary one is directional. Primary one, it exists as positive ion, and in primary it shows the number of charges on the complex. Example is CONH3 whole 6 Cl3. Both the examples are same in both the cases, whereas in secondary valency, what happens, it is equal to the number of ligands coordinated by the metal. Then we will talk about electrical conductivity. Electrical conductivity depends on concentration of the solute and then number of charges on the species which are formed by dissolution. Suppose we take the example of LiCl, already taken. Li plus Cl minus, plus minus. This is one charge, this is one charge. Both make two charges. Same as here, Ca Cl2, Ca2 plus and 2Cl minus. Here what? Two charges. Here two charges. We add them. It gives total four charges. Clear? Then we will talk about crystal field theory. So before taking the crystal field theory as the main topic, let's talk about the limitations of valency bond theory, also popularly known as VBT. So most of the complexes are colored. Most of the complexes are colored. So as a result, there is no proper explanation, and magnetic properties vary with temperature. Then let's come to salient features of crystal field theory. The attraction takes place between metals and ligands, which are purely electrostatic, and bonding takes place between ion-ion and ion dipole interaction. And ligands act as point charges. So let me show you the diagram of octahedral. So this one is the energy. This is dxy, dyz, dzx. This is the T2G part, and this is dx square minus y square dz square. It is the Eg part. So this is the structure of octahedral. Then let me tell you something about weak and strong ligands. So weak ligands have generally small value of delta, but they have high spin complexes. Whereas in strong ligands, the delta is large, but they form small, means low spin complexes. So it is stated that high oxidation state leads to larger splitting, and as d orbital increases, splitting also increases, and they create order 3 less than 4 less than 5, means 3D is less than 4D is less than 5D, in which 5D has low spin complexes. Then talking about the geometry, in that geometry square planar is less than octahedral is less than tetrahedral, which creates 4 by 9 delta. Then at last let me talk about spectrochemical series. So what is spectrochemical series? The variation of magnitude of crystal field splitting along with the nature of ligands in a regular order is called as spectrochemical series. Let me again tell you the definition. The variation of magnitude of crystal field splitting along with the nature of ligands in regular order is called as spectrochemical splitting. So this was the short video about the episode 4 of chemistry. So do subscribe to the channel, hit the like button, share with your friends to learn more. Thank you.